Recording in progress.
Yeah. Comes on everyone. Let's start off. This was the last thing that we did. It's a pretty good one, especially the second part is a proper advanced question. Okay, let's go ahead with the question. We have a particle projected with u and theta. So lands on the ground. So basically restitution is E. And so on. Let this range be R1. Let this range be R2. Let this range be R3 and so on. So E is the quotient restitution of the ground. Find R1 is 2, R2 is 2, R3, R4, and so on. Get it, easy one. You must have seen this when you throw a ball onto the ground, it doesn't come to the same height. E is not equal to 1, so it will bounce smaller and smaller heights. So range also gets messed up. So find the ratio of the ranges. Others do keep your cams on. We have one answer, right, Vihan? 30-40 seconds more. One thing is clear, see, during an oblique collision, only the component along the normal will change. The horizontal component is not affected. Let's see. So when this is projected with u and theta, if you look at the velocity, so this guy is u cos theta, and this guy is u sine theta. So this thing goes here, and finally when it is landing on the ground, if you look at the velocities, again, same thing. This will be u cos theta, and this will be u sine theta. And we know whenever you hit a wall with speed u, you're going to bounce back with the speed eu. That means when this thing bounces back here, if you look at the velocities, this vertical component becomes eu sine theta. The horizontal component will remain same. So every time you collide, the vertical component gets messed up. So again, when you collide here, next time, when you're bouncing off, this time it will become e square u sine theta. and this will be u cos theta. So the horizontal component doesn't change, only the vertical keeps on changing. All right, right, Puroja, you got it. Now, if you just look at the first case, the range R1 is nothing but time of flight, which is 2u, u cos theta. I'll just write range is nothing but ux into time of flight. So R1 is u cos theta. Time of flight is 2u sine theta by g. This is your regular formula. R2, if you see the horizontal velocity ux will remain same. So what gets messed up is the time of flight. 2 eu sine theta by g. So actually, if you see, this is E times R1. Similarly, if you see R3, again, u cos theta, 2 E square u sine theta by g. This will be E square R1. So their sequence will be 1 is 2, E is 2, E square is 2, E cube is 2, so on. It's a geometric progression. Clear? So every time you hit the floor, only the vertical component changes, horizontal remains same. So the range becomes E times. Easy? Clear? Next one. Any doubts on this? Arnav, Ariman, clear with this? Next thing. Let's say we have a wall here. Coefficient of distribution is E. Particle is projected with u and theta. It goes here, hits the wall. So let's say this distance is 2r by 3. After hitting the wall, it comes back and lands on the ground. So this is what would happen. Let this distance be x. R is your regular range, u square sine 2 theta by g. Find x. The particle is projected with u and theta at a distance of 2r by 3. There is a wall. Hits the wall, comes back and falls on the ground. Find x. Do you remember we have done things like this in kinematics? But there I taught you in terms of perfectly elastic collisions. There we didn't know what was E and stuff, so we did where E is equal to 1 ka case. Get this, you got a minute. There is no need to use big calculations and stuff. So think logically, we'll figure it out. Yeah, right, Puraja. See, think about it. If there was no wall, what would have happened? If there was no wall, you would have simply gone like this So if the wall was somewhere here, you would have landed at a distance of r by 3, because the total was 2r by 3. You will land at a distance of r by 3. Now, ask yourself, at this point, what are the velocities? The horizontal velocity u cos theta, that is not going to change. Vertical velocity is vy, so that is something there. After a collision, what will happen to the velocities? After a collision, the horizontal velocity becomes eu cos theta. The vertical component remains vy. Since both have same vertical velocity, the time of flight is same, isn't it? Time of flight depends only on the vertical velocity. See, both are at the same height. Both are having same vertical velocity. Then isn't the time of flight same? Since vy does not change, the time of flight is not affected. Then we know range is equal to horizontal velocity ux into time of flight. If the time of flight is same, therefore time of flight is same, the range is proportional to ux. Now you tell me, for u cos theta, if you travel r by 3, for eu cos theta, how much will you travel? E times r by 3, isn't it? Makes sense? For u cos theta, you travel r by 3. For eu cos theta, you'll travel e times r by 3. Make sense? So therefore, if you see, so since ux becomes e times, the distance becomes e times. So basically, it's like a reflection of a mirror, but it becomes e times. Therefore, x is er by 3. Is that making sense, everyone? So there is no need to use any big calculations and all that stuff. You can just see symmetry wise and finish it off. If he had been equal to 1, you would have got r by 3 exactly. Is this clear? Does this make sense? Ojas? Clear, na? Jainil? Abhinav? Daksha? Got this? Devansh? Ansh? Devika? Arush? Clear? Next one. Let's see something better. Similar one. We have a wall here. We have the floor here. Let's say this distance is r by 2, means half of the range. So a ball is projected with u and theta. So this ball goes here, hits the wall at the highest point, and then bounces here, falls on the ground, and then it bounces again and comes back to the point of projection. You getting how it is? So the ball is projected with u and theta. It hits the wall at h max. Then lands on the ground and bounces back to the point of projection. Now, this does not happen for every value of E. This happens for a very specific value of E. Find E. Hmm. Right behind. Try others. Take a minute or two. Up or they'll get a quadratic you have to solve. Right, Ishana? नहीं अंश. Let's see. So particle is projected with even theta. This thing goes and hits at h max. So if you're hitting at h max, your velocity will be u cos theta. And if you hit with u cos theta, you will bounce back with eu cos theta. And just now we saw this distance was r by 2. So if you bounce with eu cos theta, you will land at er by 2. Now, when you're landing back on the ground, if you look at your velocities, your horizontal velocity is eu cos theta. Your vertical velocity is u sin theta. After collision, your velocity vertically will become eu sin theta. Horizontal velocity will be eu cos theta. So that is the thing there. So when you're hitting the wall, the horizontal component becomes eu cos theta. When you're hitting the floor, the vertical component becomes eu sin theta. So your horizontal velocity was eu cos theta. The vertical was u sin theta. After the collision, your velocity becomes vertically eu sin theta. And this is eu cos theta. So for this, what will be the range? So time of flight will be 2 times eu sin theta by g. Range will be ux into time of flight. You will see this will be eu cos theta to eu sin theta by g. This thing comes out to be e square r. That means after hitting the ground, it will go here and will land here again. This range is e square r. Now you can see from here the total distance e square r plus er by 2 must be equal to r by 2, isn't it? E r gets cancelled, we end up with 2e square plus e minus 1 is equal to 0. You will get two roots, e is equal to half and minus 1. Minus 1 is not taken, so e is equal to half. Easy. So the projectile and this thing combined. try to understand the meaning of E, right? What is the meaning of E? How much you recover from the deformation. E is equal to 1 meaning full recovery. E is equal to 0 meaning no recovery. If you say E minus 1, what does it even mean physically? Instead of recovering, you lost even more. Meaning during the collision, body deformed. When the bodies are, opening up, when they're separating, they lost even more. Making sense? You didn't recover anything, you lost even more. It doesn't make any sense.
So it won't be like that, like the velocity separation become negative, so like they're getting closer to each other or something like that.
Think, Nare, you're saying after deformation, it's even deforming more.
Yes.
That thing doesn't make sense only.
Yes.
Clear with this, everyone? Got this question? These questions are not tough, but should have an idea. They can make the questions even tougher. What if the wall itself is going with speed v? So you can have variations of this, but in all these questions, generally the theme is same. Clear? Next one. Clear now, Ojas? Nikhil? Arnav? Arya? Clear? Great. This is a top view. We have a striker, mass 3m, radius r. This is traveling with speed u. Here we have another coin. We have another coin. They're just touching each other. Mass m, radius r, mass m, radius r. Identical. This is the top view. And let's say E is equal to 1. Coefficient of distribution is equal to 1. So find the velocities after collision. So basically, this 3m is colliding with m and m at the same time. They are just touching each other. Okay, I didn't draw that properly. They are just touching each other. I'm pretty sure you must have seen this in caroms. You don't guess, Ray. Try to solve. Okay. Let's see. Try. I'll give you a minute more. It has a little working. But if you remember, the process is still the same. Huh? What is step 1? Draw the final velocities. Step 2, right? Resolve the velocities along the normal perpendicular to the normal and conserve momentum. Step 3, right? Restitution. Meaning theme is still the same. So just to give an idea here, if you see when they're colliding, If you draw the common normals, this will be the line joining the centers. What will be the angle between them? Equilateral triangle, right? It will form 60 degrees each. So these half angles are 30 and these half angles are 30. Now, if you see, the force will be along the common normal. So this will be the force along the normal. This will be the force along the normal. So the mass ends will gain velocity along the common normal. If you're applying force along the normal, velocity will be along the normal. And if you see by symmetry, this 3m will still go the same way. So this is how the final velocities will look. The 3m, let the velocity be v1. This guy will go with v2. This angle is 30. This guy also will go with v2 and 30. Is this diagram making sense? They both has to go that way. There is no other option, because think about it. For this m, the only force coming is this n. There is no other force, so you have to go that way. You can't go in any other direction. So great. So step one, conserve momentum. So initially the horizontal momentum is 3m into u. Finally, it is 3m into v1 plus m into v2 into cos 30 two times, because two of them are there. So this will be 3u is equal to 3v1 plus v2 root 3. This is your equation 1. Vertically, there is no need to conserve momentum because we took a vertical component and this we took a vertical component will anyway cancel. So it was anyway symmetrical. So it works out. Momentum conservation. Yeah. Now, how do you apply restitution? Again, ask yourself, in the formula E is equal to V2 minus V1 by U1 minus U2. First thing, when you observe that, it is only actually between two bodies, right? So restitution E is applied only between two bodies. You can't apply between all three at the same time. That is number one conclusion from that. Second thing, if you look at V2, V1, U1, U2, how did you even solve oblique collisions in the first place? If you go back to the process of oblique collisions, this is what we used to do, right? Resolve the velocities along the normal, then apply head-on collision. So apply restitution and solve, isn't it? That means ECA formula may V2, V1 and U1, U2 are velocities along the normal. They're not the complete velocities, isn't it? Is that making sense? Because the perpendicular components are unaffected, they don't come in the picture. If you see, even we wrote that in the statement also. There. Relative velocity of separation along normal, approach along normal. So in the formula, E is equal to V2 minus V1 by U1 minus U2, these are velocities along the normal. They are not the total velocities. I hope that is making sense. Because the only ones responsible for the deformation are the velocities along the normal. Perpendiculars don't care. So there's no point in writing full velocity V2 minus V1 bar. So if you look at the velocities, so before collision, this is just before collision. This guy is going with you. You can choose any two bodies. I will just choose the upper two because the bottom two are symmetrical. This is your normal. This is 30 degrees. So here U1 is U cos 30. u2 is 0. So you should take velocities along the normal. And what about this thing here? So this will be v1 cos 30, and that is v2. So when you apply the formula, E bar is equal to v2 bar minus v1 bar by u1 bar minus u2 bar. These are components of velocity along the normal. Therefore, E is equal to v2. v2 का place में v2 is only there. v1 का place में v1 cos 30. u1 minus u2. u1 का place में u cos 30, and u2 is 0. E is equal to 1. So we have v2 minus v1 cos 30 root 3 by 2 is equal to u root 3 by 2. This is your equation 2. This is one thing. So be careful about the restitution. You just can't directly dump v2 and v1 there. You should take the velocities along the normal. You can write for 3m and the lower ball, you'll get the same equation. And restitution is applicable for, between two bodies of collision. Meaning we are actually talking about when these two collide, this deformation ka discussion kar rahe hain. And because it is symmetrical, we don't write for the lower one. But imagine this question had been m and r and 2m and r. Then you have to apply restitution for this and apply restitution for this. You have to apply for both of them differently. And not only that, now this velocities also will be v2 and this will be v3 now. So the whole thing will get messed up. That will be pretty complex. But clear with the equations. Then you're done. Just a matter of solving now. Equation 1, equation 2 solve. Equation 1 is 3u, 3v1, v2 root 3. This thing is v2 minus v1 root 3 by 2 is equal to v2 root 3, u root 3 by 2. Take v2 from here and dump it in this. 3u is equal to 3v1. So v2 will be root 3 into v1 plus u root 3 by 2. This will be 3u, this will be 3v1, this will 3v1 by 2 plus 3u by 2. 3u by 2 is 9v1 by 2. v1 is u by 3. And what is v2? v2 will be v1 plus u, 4u by 3 root 3 by 2, 2u by root 3. There. So this is the final velocity. So this 3m is going horizontally with u by 3. These two coins have gone this way with 2u by root 3. This guy has gone here with 2u by root 3. Check. Now I can give any masses and any restitution. As if you got the concept, it is done. Momentum conservation and restitution. Now, only thing you have to be careful when you apply restitution, these are the velocities along the normal. Don't take full velocities. Is that clear, everyone? We are going to again encounter something like this in rotational mechanics. There we are going to define it a little bit more. Next one. Any doubts on this? Clear, na, Daksha? Got this? Purvaja? Pratik? Vihan? Ishana? Clear? Sharman? Surya? Adi? Clear? Next one. Next one is a good one. velocity of a ball before collision is u bar, which is 2i plus 3j. After collision velocity v bar is I minus j. Find the coefficient of restitution. Meaning nothing is mentioned how is this colliding. So there is some random wall here. You went with velocity u bar, you collided with this thing, and then you bounced off with velocity v bar. There is no other info. That's it. You know, initial velocity, final velocity, find restitution. Think, I'll give 2-3 minutes. How do we even start? What is the idea behind it? Wall, nothing. That's it. The wall is stationary only. You know, you like to make things more complicated. जितना है उसमें it is already tough. Wall is stationary. Let's not mess with the wall right now. Now, let me give you a hint. Devansh, you got it. Let's see. You should have seen this once. You know, if you have not seen this question before, you won't get an idea what to do. So the idea is this. Now you tell me, when you collide with the wall, which component of velocity changes? Only along the normal, right? So during collision, the force is exerted along the normal. That means whatever is your change in velocity is because of this force only. And we know force is nothing but mass into acceleration, and acceleration is nothing but mdv by dt. From this, can I make a conclusion? The force is parallel to dv bar. Is that making sense? That means this normal vector which is there, the normal vector is parallel to the change in velocity vector because the force is along the normal. Is that making sense? So if you're applying force in this direction, the change in velocity also must be in that direction, because anyway the parallel component doesn't change. So if you take the change in velocity vector, which is nothing but v final bar minus v initial bar, That would be v final minus v initial, I minus this thing minus I minus j minus 3j minus 4j. You want unit vector, so delta v cap is delta v bar by mod delta v, which is minus I minus 4j by root 17. That means if you take n cap, this is the unit normal vector. Because you said they're parallel, so unit vectors must be same. The unit normal vector is delta v cap. Minus I minus 4j by root 17. There, I found the normal. Now what? Now think I'll give you one more minute. So that is how you find the information about the wall. I know the normal. No, Daksha, that's not the answer. But is this making sense, everyone? During a collision, the force is along the normal. That means acceleration is along the normal. So change in velocity is along the normal. So if I know v final and if I know v initial, the difference must be along the normal, the vector. Now look at the second part. That means, so this is your normal vector. So if this is u and if this is v, if I take this angle to be theta and this angle to be phi, right? So during collision, you tell me which component changes. So if you collide here with the speed of u cos theta, you will go back with the speed of v cos phi. Isn't that same as u cos theta? When you come with u cos theta, you should bounce back with the u cos theta. That means the v cos phi, which is the final velocity and the final angle, I don't know both of them. Right, Poroja, but minus a nahi aayega, just take magnitude. Right, so v cos phi is equal to eu cos theta. Therefore, we get E is equal to b cos phi by u cos theta. Agreed, everyone? Now, what is u cos theta and what is v cos phi? U cos theta and v cos phi are nothing but component of vectors along the normal, isn't it? So how do we find that? If I give a vector a bar and if I give a vector b bar, we did this in vectors. So if you want to find this component a cos theta, so component of a bar along b bar is nothing but a cos theta into b cap, which is a bar dot b bar by mod b bar. I hope you remember that. So u cos theta is nothing but u bar dot n cap by mod n cap. Does that make sense? A dot b. Similarly, what is v cos phi? V cos phi is v bar dot n cap by mod n cap. Yes, you're done. So E bar is nothing but v cos phi u cos phi, which is v bar dot n cap. Denominator will cancel anyway. U bar dot n cap. Put a mod, because technically speaking, you should take minus u bar ka angle, because the angle between two vectors is tail to tail. Put a mod. Now get the dot product, you're done. So I'll write a more general formula here, but have a look at this. This is how you actually get the Eka value. Even you don't have, it looks like insufficient information, but you can figure out everything. Any doubts on this page? Right, Ishan, you all got it. Is this making sense? So you want u cos theta and v cos phi. These are nothing but the component of vector u bar and v bar along n bar. What is n bar? Delta v bar. So we got v bar dot n cap by u bar dot n cap ka mod. U bar was 2i plus 3j. V bar was I minus j. N cap was minus I minus 4j by root 17. So if I do the dot product there, so v bar dot n cap will be minus plus 4 by root 17 by minus 2 minus 12 by root 17. Put a mod. Root 17 goes off, you end up with 3 by 14. Make sense? Now I can write a vector form here. Look at this. V bar dot n cap is nothing but delta v bar by u bar dot delta v bar. This can be written as v bar dot delta v bar is v bar minus u bar by u bar dot v bar minus u bar. V bar dot v bar is v square minus v bar dot u bar by this is u square minus u dot v bar. There, that is a vector form for coefficient of restitution. I'm just messing with that minus sensor because I have a mod. I'm taking advantage of that. It doesn't matter. Mod will take care of itself. There, this is the vector form to find restitution if you know u bar and v bar. So saves you time in the exam. You can skip everything and directly put this. You'll get the answer. We can use bar na, because if I include a bar here, extra is maybe aayega na, denominator will cancel off. Isn't it?
So like when we got n cap, we did that by dividing by the magnitude. So is it necessary?
So they'll cancel a numerator denominator. No, but I have to show you na. Maybe in this problem it didn't matter. In some other problem it will matter. So, what if I just ask you find the component of velocity along the normal? What will you do?
Sir, can't we use that same normal velocity and just take the dot product of those two?
Then end of the day, you're doing that only record. If you say n bar by mod n, you're doing n cap only.
Yes, sir.
You're doing the same thing. I'm just keeping it theoretically right, nothing else. When you say direction is same, means unit vectors are same. Vectors are not same. You're talking about answer. I'm talking about concept.
So we can just like take the n bar minus I minus 4j and just take dot product using other method, right? Multiplying this part.
But that is not the right way to do. You will get the answer. That is not the right way to do.
So why?
You tell me. So if I say two vectors a bar and b bar are parallel, means what? A bar is equal to b bar.
No, sir.
Then what is same then? Direction of a bar is equal to direction of b bar, right? Unit vectors are equal. But what you're saying, the answer will come. Why? Because numerator or denominator में दोनों में है ना n bar. So you're saying I'll make this n bar and make this n bar. Luckily that n bar in the denominator got cancelled. You're getting the thing? You will get the answer. But the reason is because there is a numerator denominator where ratio gets cancelled. But what if I ask you, find the velocity, initial velocity along the normal? Then you still have to take n cap, right? You're multiplying with an extra magnitude there.
Okay, so then we would have to take u cap.
Then you have to take, basically why bol raha na, what you're saying will become like this then. U bar dot n bar by mod n bar aayega. N bar by mod n bar is n cap only.
Yes, sir.
It is the same thing. Then you have to use this and you'll get it. Got it, na? All I'm trying to show you is when you say normal vector is parallel to delta v bar, it doesn't mean n bar is equal to delta v bar. That is wrong. N cap is equal to delta v cap. That is right. Bus.
Yes.
That's the thing I wanted to show you. I don't want to take a liberty and solve. See, when you're a student now, you can do all these things, Vihan. You are right. If I'm a student, I will do all that things. When you're a teacher, you have to be careful. Because someone will start assuming this is valid for every time. And I have seen people doing that. They're at n bar is equal to delta v bar. Why? They say, sir, you said they're parallel, na? So they're equal. It's like saying I cap and 1000 I cap are parallel and equal. They're parallel, right? They're not equal. So
Yes.
that way. But anyways, others got the discussion here. This thing is clear, the vector form. So if you just give me u bar and v bar, this is how you do. It's a pretty good question. The question looks like as if there's an insufficient data and it looks like something weird, but there. Devansh, did you do something similar to this?
हाँ सर इम्पल्स का डायरेक्शन निकाला.
Yeah, why it was basically that will be the normal. But there, this formula will save you time in the exam. All clear? There, that's a bit about collisions. The next thing is variable mass system. So in variable mass system, primarily we deal with when mass is changing. So in this, you have few cases. First thing is your water jet problems. So let's say we have a wall here and E is equal to 0. That means the water will hit the wall and stop. Rho is the density of the liquid. A is the area and V is the speed. In the second case, E is equal to 1. And this water jet is hitting at an angle theta. And it bounces off. In both the cases, find the force acting on the wall. These things will again encounter in fluid mechanics, but yeah, these things are important, a bit of an idea. E is 0 regard. Hmm. See, so these kind of questions, now this is how we approach. Take a small slice of length dx. So the small volume will be area into dx. So the small mass will be rho into dv. Density into volume is rho a dx. So the change in momentum will be mass into velocity. Now after collision it comes to rest, so the final velocity is 0. Now what is force? Force is dp by dt. Rho a dx by dt into v. Dx by dt is velocity there. Rho a v square. So when a water jet hits the wall and if it comes to rest, it is the force it's going to exert. So this is what actually happens, in a river. Let's say there is a stone. That stone is at rest, but during a flood, when the speed of the water becomes 3 to 4 times, that same stone will get dragged away. Because if the velocity becomes 4 times, force is 16 times. Same mistake people do, when the river is flowing. Let's say the river is flowing here with 5 kilometers per hour. Center of the river is 25 kilometers per hour. People underestimate. They think, yaar, speed to 5 times hoga, to force bhi 5 times hoga. They go there and they'll experience force 25 times more. You drift away. So be careful. Don't cross a river which is going very fast. Now, what about the second part? Same thing we will do, but this time it is bouncing. So if you look at the velocities here, this component will be v cos theta. This component will be v sin theta. So after bouncing, this will be v cos theta. So v cos theta will reverse, v sin theta will still remain same. Therefore, the change in velocity will be 2v cos theta. I'm taking the magnitude. Same story. So change in momentum will be dm into change in velocity, which is 2 dmv cos theta. Force is dp by dt. 2 rho a dx by dt v cos theta. We get force is equal to 2 rho a v square cos theta. There. That's your force. Since the water is sitting at an angle and bouncing off, it behaves like an oblique collision. How did he equate dv to? dv is the change in volume, right? dv is a small volume. Velocity nahi hai. Okay. Maybe the symbols are looking same. Area into thickness, na? That will give you small volume. We can say dm is rho av dt. If you know fluid mechanics, you can say that. Since I didn't teach fluid mechanics, I can't. Or you're saying dx is v dt.
Yes,
Is that
sir.
what you're saying? Same thing, na? dx by dt is v. You like to go in pretty unconventional ways, right? Every time. You're not wrong. You're not wrong. Clear? So if you look at this force, right, these things exert really a good amount of force. So if you can actually take a water jet and make it into a thin stream, you can even cut steel. This is called water cutting, right? It is pretty useful, let's say with a normal building, right? The problem is when you cut with a heat or something, they just get melted. But with the water cutting, you get a pretty good finish. Let me show you how it looks. And this exerts really a good force. During a riot or something, and there's a big crowd coming up, police bring their, water cannons. So the idea was this only. They exert so much force, people get just pushed away. Look at this thing. That's your mechanical lock. That's a water jet. It just cuts like a butter. Nice, no? So this is actually used, let's say you're building a new road and now you have to remove the old road. It is very difficult to break, because of all this steel and everything. So they use something called hydrodestruction. This is what they do. They take a very high pressure jet and hit it. Metal will stay safe, but concrete will come off. There, like this. You can see how is that? So when you're when you want to destroy a building or something, normally when you take a machine and try to hit it, the problem is you'll hit the metal. It's very difficult to break the concrete. But this thing is hydrodestruction. It will just remove the chip of all the concrete. Someone has a doubt. What happens if you put your finger? Does get this kind of. Now we can't actually put a real finger. So these people have made a artificial hand, which is similar to your handcuff structure. And so let's see what happens. So they have 3 hands.
I'm quite impressed. There's even skin pattern on the in this guy.
So they're going to put the hand and just drag it.
Interesting.
Yeah, that's what would happen. The bone gets chipped off. Yeah, the edge of the finger goes off.
Seeing the tip of your finger, the bone would still be there.
For the most part, you can took a little chunk out of your bone right here, but your flesh would most definitely be swiped.
Now, the thing, the mistake is this. You think you can just put the hand and remove it. You're forgetting something. The force is rho a v square is such a high force, it will just push your hand down, isn't it? So imagine someone took a knife and pushed it in your hand, and now you're dragging the hand. Isn't that how it looks? This water jet will just penetrate your hand and you're dragging it out. So you will rip your hand apart actually.
All the time.
These guys do more.
We'll see how fast. Oh,
There.
That's some damage.
Yeah.
So Abhinav, don't do this. Don't put your hand under a water jet.
Test here across the
There. That is how your hand is going to become. In case you don't want your hand to become like that. So you see a water jet. I know you get a feeling like haath rakh ke dekhte hain, but yeah, hand won't be there. And if you have really good pressure, right? Look at this. The rho a v square which I was talking about. Yeah. So if you go to Dubai or something, this is like a water ride. There, you can see that rho a v square. That is balancing the weight. So that water jet, right, exerts really good amount of force to balance the weight. So this is like a ride. This might look like fun, but imagine both your legs get stretched away in opposite directions. Then you're gone only. Getting it? So movies may, right, everything they show, it looks like, like for example, hero sees a horse for the first time in his life, climbs the horse and starts riding it. But in real life, if you actually try to ride a horse, anyone tried riding a horse? After 5 minutes, when you get down from the horse, both your thighs are so stretched, you will walk in a very weird way on the ground. Getting it? Your thighs will swell. Just movies mein hota hai. Hero just gets on the horse and starts riding like, as if it's a very common thing. No, this is there. No. There, he carried a person also. That thing does exert a good amount of force. So there. So next time when you go for a protest, be really careful. If they hit you with a water cannon, there's a good chance you will break your ribs. You will get pushed away if you get really, hit it on straight. And anyway, if you're going for a protest also, Mumbai mein they use this kachra water too. First of all, you'll get infected. More than, they won't use pure water to hit you. So that's a problem there. So I think there was an incident like this, in UP or Kashmir now. There was a police, 50 police were there, 50 to 60 police were there. They have 2 water cannons and a crowd of 3,000 to 4,000 people were coming to attack them. And the police people know, boss, kuch nahi kar sakte, we need to run away. 50 people, you can't stop a 3,000 crowd, and right, and you're not allowed to shoot them with AK-47s and all, right, stone pelting and stuff. So the police person, right, the chief who is there, he said, okay, let's do one thing. We have to run away anyway, but we should not leave these idiots. So you know this election ink they have. If you put that ink right, it stays for almost a week to 10 days. So they brought the ink, mixed it in the water, and as the crowd is coming to beat them, they started spraying water on them, and they ran away from there. That day evening, 400 to 500 police people went house to house. It is simple to catch, right? You go into the house, whoever has a color, catch them and bring them, because the color won't go for 15 days. So during daytime, you'll come as a crowd, right? But during night, when you go to the house at 12 o'clock, right, 3 to 4 police are going to each house and knocking the door and going inside and looking at everyone's face. No color, you're safe. Whoever has a color, catch them and bring them to the station, beat them right and left, and leave them next day. After 2 days, again go and see whoever has a color, catch them, beat them. And these people, even the crying are, boss, you already have beaten me yesterday. I said, that's not the point. You have the color. As long as you have the color, you are going to get beaten right and left. So people got beaten right and left for 10 days. The next time when there was a protest, when the crowd was coming, all these people needed to do was point the water guns and everyone was running away from there. So that is what you can do. There's no need to fire an actual gun. You show the water gun and people, you can relate to that incident. So there, it works. So you create a fear like that. So there is a saying in China, in order to control a crowd of 100, you kill one person. You kill one person, the remaining 99 will get scared and will be in control. So something like that. Now the same question, we can go one step further, but more about this we will do in fluid mechanics. Let's say you made a 90 degrees pipe. Now this is a reason when you have a water supply coming into a city, right, you don't bend pipes. Something really bad happens if you make the pipes like this 90 degrees for large supply. Ghar pe chalta hai. So let's say we have a water entering with speed v, rho is the density, area A, and it comes out with speed v. Find the force acting on the pipe. Water enters and leaves the pipe. With speed v. Find the force on the pipe. We'll wrap up the chapter today. Thursday we'll start off with rotational mechanics. Yeah. So this is the idea. See. So the water which is entering here will hit this wall and stop. So this will become rho A V square. Now when the water is leaving, by Newton's third law, if you are pushing the water out and hits the wall with rho A V square, by Newton's third law, you'll get a force of rho A V square. Isn't it? The water which is going straight will hit, right? So this velocity becomes 0 and it is turning 90 degrees. So when you're hitting this wall, you'll exert rho A V square. When you're leaving this, container, you'll exert a force in the backward direction. So you get a force of root 2 A V square at 45 degrees. This is the net force on the pipe. Clear? So just now you saw that thing, right? I showed you the person was flying in there. So that's what is happening. When the water jet is pushed down with a speed V, he is getting a force upward in the rho A V square direction. Clear? Take a break. Come back with 7. Any doubt so far you can ask. Won't both the action and reaction force? No. The force when the water is pushing away, right? It is pushing the pipe backward, isn't it? Newton's third law, force and reaction will be on the opposite bodies, right? They won't be on the same body. So treat like this, water as one system and the pipe as one system. Okay. Okay, come back in 10 minutes. Chalo, camps on everyone. The next type of category is a chain questions. Let's say someone is pulling the chain with speed u. So chain is pulled with constant speed u. Find F. Neglect any gravity. So someone is pulling the chain out of the heap. Initially, the chain is stationary and you're pulling it from the heap. Find that force. Similar to the water, the water jet problem. Same thing. You take a small piece dx. The dm will be lambda into dx. The change in momentum, initially the heap is at rest and the chain suddenly moves with speed u. Force will be dp by dt. Lambda u square. So that means whenever you want to pull the chain out of the heap, now you need to understand, most people what they think, sir, velocity is constant. So acceleration is zero, F is equal to ma. That itself is a blunder. You can't apply F is equal to ma when mass is changing. Hope you remember that. So F is equal to dp by dt is always valid. That you can always use. Clear? Based on this, let's say someone is pulling the chain out of the heap with force F, speed u, and let this length be x. Gravity is there. Find the power due to the external force as function of x. Easy one. See, the idea was this. So when you're pulling out of the chain, two things are happening. Your force has to balance the weight of the chain. So you're applying a force, you have to balance the weight lambda xg. On top of it, since the chain is being pulled out, you have to apply a force of lambda u square also, isn't it? If you pull the chain out of the heap will pull you the same force, isn't it? So there are two forces there. The heap is pulling you back with lambda u square. So you have to exert lambda u square to pull out the new chain, and you have to apply lambda xg to balance the weight of the chain which is already hanging. So the total force will be lambda xg plus lambda u square. We are assuming u is constant. If it is accelerating, that's a different story. Then again, we will get f minus lambda xg minus lambda u square is mass into acceleration. We are assuming u is constant. So power will be f into u. There. So your force has to do two things. One, pull you out of the heap. Second, balance the weight which is already out. Clear, everyone? What extra force?
So the lambda u square.
Uh-huh.
So lambda u square.
Uh-huh. So why did you get lambda u square here then?
So because we're pulling it with some velocity.
Then here? So you mean to say the heap is already moving with speed u?
Okay. So to
The
make
chain is
that
already
heap
at rest.
move. Okay. So
The lambda u square is the speed force required to move that heap, right? Out of the chain. Out of the heap, you need to pull out a link.
it's
Now in
at
this,
the
we
rest.
have, yeah. So we have a chain hanging. They're all chain-based problems. So we have a chain, mass m, length L. Chain is held at rest vertically. And released. Now, after releasing this is what happened to the chain. The chain, after hitting the floor, it started sliding to the side. Are you able to visualize how it is? So it is hitting the floor and it is sliding to the side. Find the force due to the chain on the floor as function of x. So when X amount of chain has hit the floor, how much force is the chain exerting on the floor? It doesn't matter. It's traveling, let's say, horizontally, meaning if it is coming with U down, this will also slide with U down. No? It's sliding down to the side. If it comes to rest, then you'll get a pile, isn't it? It doesn't matter because the vertical velocity is becoming horizontal. So your vertical direction of momentum is changing, isn't it? So that exerts a force. Let's see. Now here there are two things happening here. Now if the chain has x on the floor, that means the chain has fallen down by distance x, isn't it? That means this will have a speed v is equal to root 2 gx. So a small part of the chain dx is hitting the floor and going horizontally. So vertically it is stopping. So how much will this force be? This force will be dp in the vertical direction is lambda dx into v. The force will be dp by dt. So basically the same thing, the force from the heap, lambda v square. This is lambda 2gx. This is a force on floor due to collision. Most people, do till here, but you're forgetting something. I didn't ask you force due to collision. I said find the total force due to the chain on the floor. So the thing is, there is already some chain on the floor, isn't it? There is an x chain on the floor. So this will act a weight mg, which is lambda x into g. And this is another normal reaction n. So there is actually two forces. One force is due to collision and one force is due to the chain, which is already on the floor. So the net force on the floor will be 2 lambda xg plus lambda xg. This is due to collision and this is due to the chain on the floor. So the answer is 3 lambda xg. Lambda is m by L, so yeah, if it becomes a heap or it doesn't matter because you're taking the change in vertical momentum, isn't it? So if this had become a heap, also the answer would remain same. But a heap ka problem ye hai, if it becomes a heap, there's a chance, the height will change. We don't want to get into that picture. So easy. So basically, these are some chain ka models. So if you see the water jet chain, they're kind of similar. There it is rho a v square, here it is lambda v square. Clear with this? Now in this, we have another type of problems, which we have done in NLM, if you remember. Rainwater falling into a, truck. You should refer them there. We did these things in Newton's second law. There. So the rainwater is collected at a rate of 5 kgs per second, find the force. So there we have done questions on these things. So these also actually belong to variable mass system. This was a better question. So we have a truck where the rainwater is falling and you're also applying a force which is changing with time. So we wrote F as dp by dt and there, this was the integration. You should definitely refer this. So refer page 77. So I'll just add this here. So those are other type of models that you have. Then comes, your rocket propulsion. That is the main one. What happens when a rocket ejects gas and everything? How does that force work out? So let's say consider a body of mass m. Moving with speed v. Eject a mass dm. with speed u relative to the body. Do you remember that thing, man jumping from the plank? Something of that sort. So let's say we have a body here, mass m, going with velocity v, and let's say someone is exerting a force F external also at the same time. After small time, let this thing be, mass become m minus dm, and let the velocity be v plus dv, and this particle dm is going with v plus dv plus u relative. I'm taking everything positive, the science will take care of it. This is F external. Now the Newton's second law says F external is change in momentum by time. So what is change in momentum? Final momentum of this body, initial momentum of the body, subtract them. So what is the final momentum? M minus dm into velocity v plus dv plus dm into velocity v plus dv plus ur. You're getting, whenever a particle jumps with the body, what is the final velocity? It is velocity with respect to the final velocity, isn't it? That ur is the velocity with respect to the new velocity of the body minus, so this is your initial momentum, minus m into v by time dt. This is your final momentum. So I have taken the big body m minus dm as one particle and dm as another particle. This is your initial momentum. Derivation is not that important, but the final result, right? It's neat. We can use that result directly with the second law. You can actually make it like F is equal to dma part. So if you try to simplify this, you will end up with mv mdv minus dmv minus dmdv dmv dmdv dmu relative minus mv by dt. mv cancels, dmdv cancels, dmv cancels. You end up with mdv by dt minus u relative dm by dt. This looks like, you got it from the differentiation, but there is a catch. This will be the speed of the particle ejected with respect to the particle. That v is not the velocity of the body. Have a look at this. Let me write down it in a more usable form in the next page. There, I didn't do anything big here. I took the final momentum, initial momentum, and subtracted it. Clear? So if I write this is the thing here. F external is mass dv by dt plus u relative dm by dt. This m is the mass of the body at time t. Mass is not constant here. Mass is being ejected outside. This is the acceleration of the body. This is the relative velocity of the particle ejected with respect to the body. That is not the actual velocity of the body. dm by dt is the rate of change of mass. So at what rate the gas is being ejected. Now, if you want to make this like F is equal to ma, we can bring the term this side. So we get F external minus u relative dm by dt is equal to m into dv by dt. So whenever you have a system like this, you can make this into F external plus F thrust force, we call this thing F thrust, is equal to mass into acceleration, where F thrust is minus U relative, so it will be opposite to the direction in which the gas is being thrown out. There, this is your final form. That means you need not worry about all that stuff. So whenever someone says, rocket is giving out gas, you can create something called a thrust force and solve the problem using regular FBD. Example, let me show you how it works. So if someone says we have a rocket, the gas is coming out with a speed of 200 meters per second. And let's say 10 kgs per second, gas is burned, gas is ejected. And let's say mass of the rocket is 50 kg. So if they ask you to draw the free body diagram, this is what you do. Because the gas is coming downward, the force will be upward. Minus sign indicates that. So F thrust will be U into dV by dt, which is 10 into 200. That is 2000 newtons. Your own weight mg. At that instant, it will be like 500. And this is the acceleration. So you can simply write F thrust minus mg is equal to ma. Is that making sense? So all the story that we did, right? You can just simplify the whatever mass you're throwing out, that will behave as if it is giving a force called thrust force, which is opposite to the gas ejection. That's it. So you got a new force called F thrust. So you can put that in the FBD and you can just solve. Is that making sense? So that thrust force is the force generated by the gas which is going backward. That is the main important result you can remember. So that UR is the velocity of the gas with respect to the rocket, not the actual velocity of the gas. And that's why it becomes very important when you design a rocket, the gas should come out as fast as possible. That's why if you see a rocket car nozzle, it looks like this. They make this part thin. Ever played with your water tap? When you close the water tap with a finger, the speed of the water increases. So by making that thing thinner, the gas comes out much faster. So you can increase more thrust force. But if you make it too small, there is a chance it will explode like a bomb. So you have to have a balance. You can't make it too small. If you make it too big, you don't get enough thrust. That's it. So if they ask you a rocket-based question, they will give you the UR, they'll give you dm by dt. You can just put a force and solve it like a regular question. Clear with this? Let's see if you have questions on this. I think that will make things more clear. But this thing can be used anywhere, like whenever there is an ejection. UR is the velocity of the gas with respect to the rocket, right? That is in your control. Why will that change? With what speed you throw is in your control. No, the actual speed of the gas is different. That is the reason it is a best equation. No matter whatever is the speed of the rocket, this value is always constant, isn't it? The thrust force does not depend on the speed of the rocket. It only depends on the UR, which is constant. You can make that constant for a given rocket. So let's say we have a rocket. Let the mass of the rocket be 1000 kgs. T is equal to 0. This is the scenario. The gas is ejected with a rate of 20 kgs per second. With a speed of 300 meters per second relative to the rocket. Gravity is there. Someone didn't design the rocket properly. So the first question, find the time when the rocket lifts off. The rocket won't lift off the ground immediately. Find the time when rocket lifts off. Find the acceleration of the rocket at 30 seconds. So in rocket problems, the biggest headache is mass changes. Get this thing. This is a simple one, mostly a mains or a CET level question. Get the other one. Yeah, first was 20 seconds. So draw an FBD. So if you look at the thrust force, now this thrust force doesn't depend on time. So this guy was 2300 into 20. So you're generating 6000 newtons and you have 1000 kgs. That means the mass is 10,000 newtons. You can't lift off. So after some time, when the mass becomes mg, so this will lift off when F thrust is equal to mg. That means M must be 600 kgs. Therefore, 400 kgs of fuel must be burned. Like I said, bad design. So what is the time then? If you're burning 20 kgs per second and you have 400 kgs of fuel to burn, 20 seconds, the rocket will lift off after 20 seconds. Yeah. And what about the second part? After 30 seconds, the thrust force will still remain same, 6000 newtons. At T is equal to 30 seconds, 600 kgs fuel is burned. That means this mass left over is 400. This will be 4000 newtons and this will be acceleration. 6000 minus 4000 is equal to 400 is equal to 5. This is the reason, once the fuel gets over, they start emptying the tanks, they start disconnecting all the fuel tanks. You want to reduce the mass of the rocket as much as possible. These numbers are bad. Generally, a rocket reaches Mach 1 speed within 10 to 15 seconds. Mach 1 is speed of sound. So that thing goes at a tremendous speed. By the time it is at full speed, I think it reaches almost 8 to 9 Mach. And the people inside are completely gone. Matlab, they are like unconscious. The acceleration is so high, they're actually in a sleeping position. The blood from the frontal lobe recedes backward and they go all unconscious. So during that time, even if the rocket blasts off for some reason, they don't even know what happened. So they don't have any control over the rocket, at least till it reaches into the space. And once it goes into the space, someone will wake up first. That is always there. That is random who will wake up first. And then they get back to the operations and stuff. So at least, and during that time when they're entering the exosphere also, right, there is no communication. Everything is literally cut off. There is no control over the rocket. If something goes wrong in the middle, it is gone. Clear with this? So this is the scenario if I ask you for acceleration. But if I want something as function of time t, same question. Let's say gravity is there. Let's say you are ejecting UR. Speed of gas with respect to rocket. Capital M is the initial mass. Lambda is the rate at which gas is ejected. Initial mass of the rocket. So assume the rocket lifts off at T0, means you have enough thrust force to move from this T0. Find the velocity as function of time t. Find the velocity of the rocket at time t. So assume the rocket lifts off at T0. Mean the thrust force is sufficient to move the rocket initially. Nere Puroja. You have to integrate. Did you integrate? Lon आएगा then. Let's see the force equation. Again, like I said, the rocket thrust, when you see, all you need to do is simply assume there is a thrust force. That's it. That is the only new thing you're learning. So F thrust force will be U into lambda. But remember, mass will change. So mass after time t, so will be M minus lambda t. That is your small m. So you have your own weight mg and your acceleration a. So F minus mg is equal to ma. So we get acceleration is equal to force, which is u lambda by m minus lambda t minus g. This will be dv by dt. So this will be u lambda integral dt by m minus lambda t minus g integral dt. 0 to v, 0 to t, and 0 to t. In case you forgot, integral dx by ax plus b is 1 by a ln ax plus b. This you should know. Integrate this, you end up with u lambda minus 1 by lambda ln m minus lambda t 0 to t minus gt. This will be u ln m by m minus lambda t minus gt. There. This is your velocity as function of time t. if gravity is not there, that means if the rocket is in a space without any gravity, then your equation becomes V is equal to U into ln m by m minus lambda t. So if you see, this is the initial mass and this is the mass at time t. So you can calculate V final. So V final will be U ln initial mass by final mass. That is taken care of, right? That minus U lambda dm by dt, all that is taken care. It's a mod. That is taken care of already. You just take it as a mod there. Because if you see now how we derived it, in this derivation also, now this dm is already taken minus, now that was taken care of. We derived this under the assumption mass is decreasing. Okay? We already assumed dm is decreasing. Right? If you're saying now, then I should take this as plus dm. No, then you would have got a plus, then you got a minus here then. So that is the thing. We have already taken care, the mass is decreasing. So the formula you derived is when the mass is decreasing already. So you tell me, is the mass of the rocket is decreasing or increasing? Decreasing. So the derivation took care of it. So think of like that. Yeah. Clear with this? So if you look at this is the reason, for example, see. Example, let's say U relative is 300. Mass of the rocket is 100. And mass of the fuel is 900. So the final velocity of the rocket will be 300 ln. Initial mass will be 1000 by final mass will be 100. 300 ln 10. So normally that's what happens when you're launching a rocket, right? You make sure the mass of the rocket is much small compared to the overall mass. That's why if you see next time when you see the space launch or something, look at that. The rocket is actually the main thing is only this much. The side may the boosters and everything makes it look like a huge thing. End of the day, what goes up is actually a small thing. Clear? Let's see one more like this. Little different one. Let's say we have a rocket which is going with speed v, mass m. So this is a gravity-free space. Now for this rocket, you have this side thrusters. These are not the main rockets. I'm pretty sure you must have seen this in movies. These are used to correct the directions. You have a side thruster, okay? And side thruster, speed as you are. Ejects gas at a rate of lambda kgs per second. And the side thrusters, right, are perpendicular. So this gas which is coming out, U relative, this is perpendicular to the rocket. We will assume the rocket is not rotating and stuff. Generally, we have two side thrusters to make sure it is not rotating. But we'll ignore that. Perpendicular to the rocket. Now, what do you think will happen? Do you think will the rocket go straight? Because of the side thrusters, the rocket will start going something like this, isn't it? It starts deviating. So after some time, the rocket becomes like this. The main thrusters are not on, only the side thruster is on. So the question is, after some time, it will deviate by delta. Find delta. The side thrusters generate a force. Perpendicular to the rocket. Due to which the rocket deviates by angle delta. Angle of deviation, basically. Find delta. M is the initial mass of the rocket. And V is the initial speed. So initially rocket is going in a straight line with speed V, then you switch on the thrusters. Don't worry about the rotation part. Basically, like there will be one or two thrusters which will maintain, if you have only one thruster, what will happen? The rocket will start spinning also like this. Let's not worry about all that. And V is the initial velocity, initial speed of the rocket. The rocket is already moving. Then you switch on the thrusters. Tan inverse U lambda T by V. Yeah, how did you get tan inverse? It's not about minus sign. Tan nahi aayega re. I hope the question was clear, everyone. Now you need to ask yourself something. Why are you so obsessed about that minus sign, Roja? Simple, say keep it simple. Don't worry so much. If the rocket ka gas is coming this way, thrust force is this way, whose magnitude is U into dm by dt. Happy? If that minus sign is harassing you, just put a mod. Just think of like this. If the gas comes this way, force must be this way. So just take the magnitude. Getting it? Don't worry about that minus thing. Now in this thing, right? Tan inverse. उसके अंदर ln. हाँ विहान. और डाल देना एक्सपोनेंशियल भी डाल देना. You just want every damn mathematical function उसमें डालने. Tan के अंदर ln डाल दिया. Now let me ask you something. When the thrust force is like this, so if the gas is coming out this, how is the force? Force is this way. After some time, when the rocket comes here, the force is this way, isn't it? Did you notice something? The force and velocity are always perpendicular, isn't it? The force ka direction is also changing. As the rocket moves, the force is always perpendicular to the velocity. Now you tell me, if force is always perpendicular to velocity, what happens to the speed? It doesn't change, right? The rocket will continue with the same speed, but direction is changing. So look at this. So initially when the rocket was here, let's say after some time rocket was here, And then let's say rocket was here. If you notice, if this was v, this was v, this was v, the speed never changes because the thrust force will be this way, which was perpendicular to the velocity. Thrust force is perpendicular to the velocity. The thrust force is perpendicular to velocity. Is that making sense? Because the gas is ejected perpendicular to the rocket, so it's always perpendicular. Since F thrust is perpendicular to velocity, we have seen this in circular motion. If the force is perpendicular to velocity, what happens? Speed remains constant. Speed of the rocket remains constant. Fair enough. So then what is this force doing exactly? So at any point of time, if you see, this is going in a circle like this, isn't it? It's going in a curve. So the thrust force is responsible for the centrifugal force. So F thrust must be equal to m v square by r, right? So, or let me keep it simple, m omega square r. But I don't know r, no? R is changing here. So basically r is messed up here, mv square by r. So what is thrust force? U into lambda. What is mass? M minus lambda t into v square by r. Send one u that side. So u lambda by v into m minus lambda t will be v by r, which is nothing but omega. Why do I need omega? Because you're asking for angle. Omega is d theta by dt. Think about it. The only thing which gives you angle is your angular velocity, which is u lambda by v 1 by m minus lambda t. So d theta will be u lambda by v integral dt by m minus lambda t 0 to t. This angle will be 0 to delta. You're done. So delta, this is u lambda by v minus 1 by lambda ln m minus lambda t 0 to t. Lambda will cancel. You get u by v ln m by m minus lambda t. That's your deviation. So the main thing in this question is to figure out speed is not changing because the force is perpendicular. It's a good one. This is how advanced paragraph questions will be there. If you see the question, once you figure out, it is easy to solve. Steps are easy, but figuring out is the main thing. And you can clearly notice here, as this thing is going on, the circle is becoming smaller and smaller. It's going in a smaller circle. It's becoming more tight. The curve is becoming more sharp. Other steps clear, everyone? So the main idea is that the moment you ask me to find delta, you're asking me to find angle. The only chapter which gave you angle till now is circular motion. So if you want theta, and one thing is clear, there is mass in terms of time. You want angle theta in terms of time. So I need to get omega. So this F thrust force is balancing your centrifugal force. Because it is going in a curve. Your R is variable. M is also variable. Mass is changing, radius is changing, but speed is constant. And thrust force is constant. So basically, because the mass is messing up, R is changing. If the mass had been constant, this would go in a circle, isn't it? That would be uniform circular motion. The reason why it is not going in uniform circular motion is because mass is changing. Is this clear, everyone? Clear with that? So there, we have done almost 56 questions. So make sure to go through them. That's the last one for the chapter. We are done with the chapter with this. So you can handle everything now, collisions. So in this chapter, if you see, there are primarily 4 parts.